Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video what I want to do is make the sort of like the video on Python virtual environments, because a lot of videos they show you like one way, they introduce the concept of virtual environments, show you a way of doing them, but don't sort of give you the grander picture, history, etc. So let's talk about it. Okay, so Python is a programming language. And in most programming languages, you download third-party packages. This means code from other developers that'll give you functions, classes, tools, frameworks that'll help you create the application you're creating. So the thing is that in Python, you use a tool called pip to install third-party packages. And basically, the default always was, back in Python 2, was that everything gets installed globally. So that means if I installed a package, it was just available to my whole computer. So any Python thing I did anywhere on my computer had all the packages I've installed available to it. And again, Python was a language I think was created in the early 90s. So back in those days, the way you would handle package management a lot is that you would basically distribute your software with all the packages that it required with it. But nowadays we distribute things through the internet, so oftentimes what happens is you distribute your software, or you have your code on like something like GitHub, and there's some sort of way of knowing these are the libraries this particular application needs, and then they're pulled from source, or they're pulled from like the repository of those packages when being installed on the computer. So if you've ever worked with like npm and node, usually if like you cloned your code from GitHub, you don't have all the libraries. You run like npm install to install those libraries after the fact. So there was different third-party ways of handling this, of what's called isolating your dependencies, meaning, okay, hey, I want to know that, hey, when I did this project, these are the libraries I needed for this project, these are the libraries I needed for this project, so that way if I downloaded it on another computer, I can quickly just get back the libraries that I had for that particular project, but you need to isolate it. And pip doesn't naturally do that. So what they came up with was the idea of virtual environments. In virtual environments, essentially what you're doing is you're just creating like a mini sort of Python copy of Python with a folder that basically pip now thinks that you're working in this is your world, and will treat this as like a whole separate world where you install packages, etc. Okay, so over there at my blog, toots.alexmercedcoder.com, I have written a few articles that if you read all three of them, you kind of get the full story. So I figured, hey, let me just do a video where I kind of go through what I cover in 3 articles. Okay, so this is like the beginning. And so in the beginning, you had kind of like 2 ways of doing it. You had virtual env, and then you also had PyEnv. PyEnv is not really for virtual environments. PyEnv is a tool to manage Python versions. So PyEnv, which I highly recommend installing if you haven't already, allows you to switch between Python versions, because sometimes you need to work with an old library for a particular project. Like in my early days, I didn't really appreciate the need for these like different like version switchers, like Node version manager, Python version manager, Ruby version manager, like all these different pieces of software. Now that I'm starting to work with like a lot of different clients, and a lot of them have like older code bases, so like my newer versions of certain languages don't work with them, so I have to kind of like downgrade. Having a version manager that allows you to switch from an older version to a newer version is actually pretty sweet. So that's what PyEnv is. But PyEnv does have a plugin for has like a virtual env extension. So again, so essentially these are the 2 routes you can go. You can get PyEnv with the PyEnv virtual env extension that allows you to generate virtual environments from, or you would install virtual env by itself, and then you would also install virtual env wrapper, which is this wrapper that gave you such more easy commands to use to work with virtual env. Okay, and this particular article works through how you would do that. Like nowadays, I think this approach isn't desirable anymore. What happened is, like, I think like version 3.3 of Python or something like that, they finally built in a way to do this. So now Python actually has a way built in. And that's kind of where we get into my second article. Okay, and here's like where I start writing about, hey, look, they built a way into Python. So let me show you that way, because technically, like if you're just new to Python, this is probably the way you should do virtual environments. Again, any of these ways work. Okay, and I think that's where a lot of people could run into a lot of issue with different Python tutorials, because different Python tutorials do virtual environments in different ways. So people get kind of confused because they think that setting up the virtual environment is intrinsic to doing the thing. It's not. How you set up your virtual environment is just how you set up your virtual environment. What matters is you get those libraries. So if I'm doing it using the built-in Python way, what I would do is I would say Python or Python 3, depending on how your Python works on your computer. Since I have Pip, I'm able to use Python 2 and 3 and several versions of both through Python, because I can just switch Pip Env can just switch which version of Python I'm using on the fly, which is awesome. So I would say Python, and then you do -m for module. So you're using the virtual environment module, venv, and then you just post a folder name. So we'll just say, hey, like dependent, deps for dependencies. So if I do this, it creates a folder called deps, and that's where my virtual environment lives. Okay, and you have all this and this you never touch. But what you would do is that before you start working on your project, I would turn on the virtual environment. So I would type in source. This is in bash. I'm in a bash terminal, which should apply if you're in Mac or Linux. If you're in Windows, please download git bash, so that way these commands kind of match up, because PowerShell is kind of a different deal. Source, meaning run source code, and I would say in the deps folder. So inside the deps folder, there's a folder called bin. Bin's short for binary. So there's binary files in here, which just means raw machine code. And particularly, I want to run a script in there that's called activate. And what this does is turn on the virtual environment. And you can see now this virtual environment is on. I can see the name of it here on the side. And I can just now install things. So I can be like pip install Flask, for example. And it'll install Flask. And if I do pip freeze, which outputs everything you've installed on pip, okay, see, it's only going to show what I've installed in this virtual environment. So all these other things like Django and Masonite that I've installed somewhere else on my computer, they don't show up here because I've isolated this particular project. Okay, or it could just be if I have like all my Flask projects use the same libraries, I could have a folder with a virtual environment that just I share among several projects using the same dependencies. That's the one thing that is kind of nice about this, that you can kind of like, it's flexible. So that's cool. Now, downside of this is that while it keeps track of version number, there's no what's called deterministic dependency tracking. What this means is like, I only installed Flask, but you see all this other stuff got installed because they're dependencies of Flask. And if I were to install this, and it goes to install Flask, it's going to install some of these dependencies, and then it might go back and install the dependencies. So just a lot of this redundant installing, because it's just arbitrarily going through the list. Now, in things like Node, you have what's called a package lock file. That package lock file tracks not only what your dependencies are, but what are the dependencies of your dependencies. That way, Node can determine, oh, you've already downloaded this dependency when I downloaded this other dependency. There's no need for me to re-download it, which speeds up the whole like downloading your libraries process. Not a big deal, okay, because again, that only matters when you initially install the dependencies. But also what matters is the versions of your dependencies, and we're not tracking necessarily the versions of those. Different dependencies might actually use multiple versions of the same library across different dependencies, so all that's not necessarily being captured here. So there is like a layer of dependency management we're kind of missing out on this way. This still works fine. I honestly like really haven't had an issue with this so far. But let's say you did want to have that extra level, have it, okay, then there's what's called Pip Env. So again, that's just the article on that. But if I go to the newest article, nope, all the way around. Oh, nope, back. Here we go, Pip Env. So Pip Env was kind of created to kind of add these extra features. You have to install it separately. But what it does, it's going to allow you to do things in a slightly different way. So what would happen is that, okay, what I'm going to do is I'm going to close this virtual environment. So you type in the word deactivate to shut it down. What you would do is you would do pip env shell. in the folder where you're creating a new project. So that's going to do things. So what that did is created me a pip file. Okay, now pip file, what it does, it's kind of like your package.json when you're using Node. So instead of tracking dependencies through your pip and then doing like pip freeze to see what your dependencies are and doing like a pip freeze to requirements.text, which is typically the practice. Okay, so usually what you do is you do, again, pip freeze, this command here, pip freeze requirements.text. Like right now I've already shut down the virtual environment, so I'm not going to, and now the Pip Envy one is now running. So you can see like this, now this is other virtual environment that's coming from Pip Envy that's running. Okay, pip freeze requirement.text. And generally what you do is you generate this file that lists all your dependencies. And then that's what you would use. But we don't need that when we're using Pip Env because we have the pip file. And the pip file lists all this stuff, which looks sort of like TOML syntax. But now what I would do is I would use pip env to install. So I would do pip env install Flask. I would install Flask. And see now, it automatically adds Flask to my pip file. See, it creates the pipfile.lock that tracks all the dependencies and the dependencies. So I don't have to do any of that myself anymore. I can just use pip env and it just tracks my dependencies, tracks the Python version that I was using when I made the thing. Where am I pulling the details from? Because here's the other issue. There's another way to do virtual environments. You could use something called Conda. And Conda pulls from an entirely different repository of dependencies. I actually ran into this issue once where I was dealing with one project where some of the dependencies were downloaded through Conda, some of them were downloaded through like just normal the pypy.org, this URL you're seeing here. So it was downloaded from all these different places, and the problem is I couldn't like replicate the environment because if I tried to install it using Conda, it would complain about the libraries that are not on Conda, and if I tried to set it up using PyPy, it would complain about the libraries that were not on PyPy because there's different versions of different things that were not available on different things, and it was a little bit of a mess. I figured it out. So it's just why it's good you want to go in there with sort of a way you're going to install things and everyone on the same page. But this is like probably the best way to do things now because you can capture a lot more meta information in here, which is going to allow for more optimal distribution of your code. But at the end of the day, the goal is the same. You're kind of setting up a virtual environment. The difference is Pip Env doesn't create, they didn't create like another folder here. It actually has like some folder somewhere where it's creating these virtual environments. But it doesn't matter. The minute I go into this folder, Pip Env is going to detect the pip file and automatically open up the virtual environment for me. Okay, so like if I cd up a folder, okay, I mean it's still kind of already detected it, so it is what it is. But it's another tool. Okay, and if you do pip env shell again, like if I were to close this terminal, okay, and then open up the terminal again, so see right now the virtual environment is closed. But if I were to do pip env shell again, it's going to detect that there's already a pip file in this folder and just turn on that existing virtual environment. And see, it just turns it back on. So you subshell and virtual environment, okay, blah blah blah, and then opens it up. Okay, and actually here you can actually see where it's storing it. So you can see that within this virtual env folder, it's creating a hash of a virtual env, and then it's running that activate command. So pretty cool. Okay, that just kind of makes life easier. Yeah, no, I like pip env a lot. It's definitely a way of tracking dependencies. But hopefully this gave you an idea of the different options you have for installing Python dependencies. And again, they all can get you to the same place of just making sure that you've somehow isolated your dependencies. Because all you're doing is you're just saying, hey, I'm creating a little virtual space where I can install my dependencies that are separate from all my other projects. So that way I can track them, whether it's through a pip file or requirements.txt. Just kind of have all of that list somewhere, so that way if I move it to another computer, I can easily replicate what libraries I had and the right versions of them from computer to computer. So yeah, Hopefully you guys enjoyed that and that helped bring context and details to your life in the Python world. Have a great day and enjoy.